Hi everyone, I am S. Sadish Kumar, Assistant Professor, RMD Engineering College. In this lecture, we are going to discuss about the topic the solution of second order differential equation with constant coefficients using Laplace transform techniques.
Now let us see our first problem. Using Laplace transform, solve y double dash plus 2y dash plus y is equal to t e power minus t, given that y of 0 equal to 1 and y dash of 0 equal to minus 2. So this is our question. Now we are going to solve how to find the solution for this differential equation using Laplace transform technique. Solution: first write the given differential equation y double dash of t plus 2y dash of t plus y of t is equal to t e power minus t. So this is a given question. Actually this y double dash, y dash and y are a function of t that you have to mention. Then taking Laplace transform on both sides, so we can get Laplace transform of y double dash of t plus 2 into Laplace transform of y dash of t plus Laplace transform of y of t equal to Laplace transform of t e power minus t. So here if we taking Laplace transform of a constant, we can take the constant outside, so that's why here we taken this to outside. Now we can apply the formula for Laplace transform of derivative. So now we have here Laplace transform of second derivative. So L of y double dash formula is s square into L of y of t minus s into y of 0 minus y dash of 0 plus 2 into L of y dash of t formula is s into L of y of t minus y of 0 plus L of y of t, that's equal to Laplace transform of t e power minus t. We can expand this Laplace transform using two methods. One is first shifting theorem and second one is differentiation of Laplace transform. So shifting theorem is easy, so now we can apply first shifting theorem. First shifting theorem tells Laplace transform of e power minus at into f of t is equal to f of, actually like this, L of f of t where s tends to s plus e. This is a formula of first shifting theorem. So using this one we can write this as L of t e power minus t can be written as L of t where s tends to s plus 1. So in this problem this t is considered as f of t and e power minus t is considered as e power minus at. Therefore here a is 1, so I have to replace here s plus a, here we take s plus 1. So this is L of t where s tends to s plus 1. That means you have to first find Laplace transform of t. Then in that answer we have to apply wherever s by s plus 1. This is the idea. So next line, s square into L of y of t minus s into y of 0 and y dash of 0 already given in that question. So use that condition, y of 0 equal to 1, y dash of 0 equal to minus 2. Now s into y of 0. So y of 0 means 1 that is given in the question, minus y dash of 0 is minus 2 plus 2 into s into L of y of t minus y of 0 is 1 plus L of y of t, that's equal to Laplace transform of t. So there is one more formula for Laplace transform. So L of t power n, already we know this formula. L of t power n is equal to n factorial divided by s power n plus 1. Using this formula we can expand this Laplace transform. So here t values, here t power n, here we have t power 1. So put n equal to 1 in this formula. We have n 1 factorial divided by s power 1 plus 1. 1 factorial means nothing but 1. S power 1 plus 1 means that is nothing but s square. So in this expansion we have to replace s as s plus 1. So next line, s square into L of y of t minus s into 1 is s, minus into minus plus 2 plus, if we expand here, 2 s into L of y of t minus 1 into 2 minus 2 plus L of y of t, that's equal to, here replace s as s plus 1, we can get 1 by s plus 1 whole square. So next line, we can eliminate this plus 2 and minus 2, and 3 terms we have L of y of t. Take that L of y of t is common. A remaining term is s square here 2s we have here, plus no number is there, that means 1 is the meaning, that's equal to 1 by s plus 1 whole square, and take this minus s to this side, that becomes plus s. So in next line, take LCM for this one, 1 plus s into s plus 1 whole square, whole thing divided by s plus 1 whole square, and in left hand side L of y of t equal to s square plus 2s plus 1 is nothing but s plus 1 whole square. So next line, expand this numerator, 1 plus s into is a plus b whole square formula, s square plus 2s plus 1 whole thing divided by s plus 1 whole square is that. If you take this s plus 1 whole square here, it gives s plus 1 whole power 4. This is the value of L of y of t. So next line, we can expand this as 1 plus, multiply this s inside, we can get s cube plus 2s square plus s into 1 s whole thing divided by s plus 1 whole power 4. This is the value of L of y of t. We can rearrange this as s cube plus 2s square plus s plus 1 whole thing divided by s plus 1 whole power 4. Now this is the value of L of y of t. Our aim is to find y of t. So to find y of t, take Laplace inverse on both sides. Then we have to proceed Laplace inverse formulas. Now we can find y of t from the last step. So y of t equal to L inverse of s cube plus 2s square plus s plus 1 whole thing divided by s plus 1 whole power 4. So here our aim is to find L inverse of s cube plus 2s square plus s plus 1 by s plus 1 whole power 4. This is our aim. So this Laplace inverse formula we can use partial fraction method, easily we can get the answer. So proceed in partial fraction method, s cube plus 2s square plus s plus 1 divided by s plus 1 whole power 4. Now, before applying partial fraction, we have to verify the degree of numerator and denominator. Here degree of numerator is 3 and the degree of denominator is 4. Therefore, degree of numerator is lesser than the degree of denominator. So, we can apply partial fraction directly. So, introduce the constants a by s plus 1 plus b by s plus 1 whole square plus c by s plus 1 whole cube plus d by s plus 1 whole power 4. Because yes, only one factor repeats 4 times, so we have to take each power for each terms. That means first term for first power, second term for 2 power, third term for 3 power, fourth term for 4 powers. This is a method. So what is the denominator degree? That number of constant we should have. This is the idea of partial fraction. Now take LCM of this step. So that is s plus 1 whole power 4 into a into here s plus 1 whole cube plus b into s plus 1 whole square plus c into s plus 1 plus d. So this is the LCM of this one. That means very simply you can understand this one. Take the maximum power in denominator. See the term here s plus 1 is there. So how many terms missing compared to this? So here power 1 is there, 3 terms are missing, that term you have to multiply here. Here 2 terms is there, 2 terms is missing, so you have to multiply 2 terms, that means whole square term. Here 3 terms are there, 3 powers are there, so multiply 1 power is enough. Here all the 4 powers are there, so that is 1. So in left hand side, s cube plus 2s square plus s plus 1 whole thing divided by s plus 1 whole power 4. Now cancel this common expression. Now in left hand side, s cube plus 2s square plus s plus 1 is equal to a into s plus 1 whole cube plus b into s plus 1 whole square plus c into s plus 1 plus d. Now our aim is to find the constants a, b, c, d. So for that we have to substitute the value of s. So now put s equal to minus 1 first, because that factor only we have. If we put here minus 1, this goes, that means these 3 terms go 0. We can easily find what is d. So this is the idea. Now put s equal to minus 1. So we can get minus 1 whole cube is minus 1 plus minus 1 whole square is plus 1. 1 into 2 is 2. Here minus 1 plus 1. That is the left hand side. Right hand side, if you substitute here minus 1 plus 1 goes 0. So 0 into anything is 0. Here 0. Here 0. All the 3 terms go 0. So only we have d. So this implies d equal to minus 1 plus 1 get cancelled. 2 minus 1 is 1. So answer for d is 1. So next line, equate s cube coefficient or s cube term. What is s cube term here? This one is s cube term. Yeah, the coefficient is 1. That's equal to, here we can expand this as a into is a plus b whole cube formula. So s cube plus 3s square plus 3s plus 1 and b into, this is s plus 1, that means a plus b whole square formula. So s square plus 2s plus 1 plus c into s plus 1 plus d. Now compare s cube coefficient. Here in this full expression only one term is s cube. If we expand this a is a coefficient there, therefore a value is 1. Then equate s square coefficient. Here s square coefficient is 2 in left hand side, and right hand side s square coefficient, if you expand this a, we can get 3a, and in this term if you expand here, b is a coefficient of s square, so plus b. That's all. Now here already we know what is a value, so 2 equal to 3 into a is 1 plus b. This implies b equal to 2 minus 3, that is minus 1. So the value for b is minus 1. So next, last constant. So we got a, d and b value. So we need only c. So for last constant we can easily compare constant term. That means putting sa equal to 0. So put sa equal to 0 here. We can get 1 equal to, here in this expression, if you put sa equal to 0 here also you can apply. If you put sa equal to 0 here, 1 cube means 1, that is a, plus next term is b, next term is c. There is no s term in last, no s term, so the same term you have to write, d. Now we know all the values a, b and d. A is 1, b is minus 1, c is unknown, plus d is 1. Left hand side is 1. Now we need c. So here minus 1 plus 1 get cancelled. If we are taking 1 to this side, so we can get c equal to 1 minus 1. This implies c equal to 0. So now we got all the constants. Just substitute all these constants in this equation. Take this as equation number 1. Substitute a, b, c, d value in equation number 1. So we can get s cube plus 2s square plus s plus 1 whole thing divided by s plus 1 whole power 4, that's equal to a is 1, so 1 by s plus 1 plus b is minus 1 by s plus 1 whole square plus c is 0 by s plus 1 whole cube plus d is 1 by s plus 1 whole power 4. Now next step, this is 1 by s plus 1, this is minus 1 by s plus 1 whole square, this term entire term goes 0, plus 1 by s plus 1 whole power 4. This is the value for this one. Now take Laplace inverse on both sides. So we can get, now take Laplace inverse on both sides, we can get L inverse of s cube plus 2s square plus s plus 1 whole thing divided by s plus 1 whole power 4, that's equal to right hand side L inverse of 1 by s plus 1 minus 1 by s plus 1 whole square plus 1 by s plus 1 whole power 4. Now apply linear property. So that means linearity property means we can split these terms. So Laplace inverse of 1 by s plus 1 minus Laplace inverse of 1 by s plus 1 whole square plus Laplace inverse of 1 by s plus 1 whole power 4. So for this we need some formulas. So first formula, L inverse of 1 by s plus a is equal to e power minus at. So this is a formula is obtained from Laplace transform of e power minus at. So Laplace transform of e power minus at equal to 1 by s plus a. From that we can get Laplace inverse of 1 by s plus a equal to e power minus at. And one more formula, first shifting theorem, that one Laplace transform of e power at into f of t is equal to Laplace transform of f of t, where you have to replace s as s minus a. Like that we have, for e power minus a means here s plus a you have to take. Now take L Laplace inverse on both sides, we can get this as L inverse of f of s plus a equal to e power minus at into Laplace inverse of f of s. That means in Laplace inverse we have a function like this, s plus some number, we can replace that number s plus some number as e power minus at, and L inverse of, instead of s plus a, you have to write s. That is L inverse of f of s. So this is the first shifting theorem. And one more formula we need, that is Laplace inverse of n factorial divided by s power n plus 1, that's equal to t power n. It's a basic formula. So these formulas are we need. So now we proceed for our problem. L inverse of s cube plus 2s square plus s plus 1 whole thing divided by s plus 1 whole power 4 is equal to, first term L inverse of 1 by s plus 1, that is of the form L inverse of 1 by s plus a. So instead of a, here we have 1. So formula for this one is e power minus at. Therefore value of this L inverse is e power minus t. So a value equal to 1. And next term L inverse of 1 by s plus 1 whole square. So we have in this form, first shifting form. So first we have to write this as s plus 1 is replaced as e power minus 1t, that means e power minus t into Laplace inverse of f of s, that means 1 by s square, using this one. Next plus is also again the same form. Here s plus 1 can be replaced as e power minus t into Laplace inverse of 1 by s power 4. First term also we can apply like this. Without using this also we can apply same formula we can apply. That means first shifting also we can apply. That means replace 1 by s plus 1 as, that means s plus 1 as e power minus t into Laplace inverse of 1 by s. Laplace inverse of 1 by s is nothing but 1. So 1 into e power minus t is again e power minus t. We can get the same answer. Okay, now here e power minus t minus e power minus t Laplace inverse of 1 by s square is obtained from using this formula. So here this denominator s square need to be write n plus 1 form. That means 2 can be written as 1 plus 1. So n equal to 1 here. If we put n equal to 1, 1 factorial, that is the numerator is 1. So 1 factorial is 1 is correct. So 1 factorial by s power 2 equal to t power 1. That means put n equal to 1 here. So we can get that is t. T power 1 means 1 by s square. Next e power minus t 1 by s power 4. That means the denominator we have to write n plus 1 form. That means 3 plus 1 form. 3 plus 1 means numerator should be 3 factorial, because 3 means n, that is n plus 1 form. So here 3 factorial is missing, so you have to multiply and divide 3 factorial. So 3 factorial into L inverse of 3 factorial divided by s power 4. So next line e power minus t minus e power minus t into t plus e power minus t 1 by 3 factorial means 6. So this one is using this, here put n equal to 3, we can get this expression 3 factorial by s power 3 plus 1. That means here you have to replace n equal to 3. So we can get the answer for the Laplace inverse is t cube. So now take common term e power minus t outside. We can get 1 minus t plus t cube by 6. So this is nothing but our y of t. So this is our general solution for our given differential equation.